Alright, in this video we will start trigonometry, and we'll begin by talking about angles. There's quite a few things in this video, and most of it's review, so we'll just get right into it. So angles. You've seen before that an angle is just a degree change between two lines. Usually one is flat and then one goes up somewhere, and say this one, for instance, is 45 degrees. You know that in a triangle, the three angles have to add up to 180 degrees, and there are formulas for other shapes. So, we're going to talk about angles pretty generally here, and we're going to talk about standard position. So, standard position is when you have a unit circle here, and your first line is always going to go from the center of the axes to the right. So the first line is always at 0 degrees, and then when you create your angles, it goes counterclockwise. So it goes in that direction there. So for instance, if we want an angle of 300 degrees, it would be here, and this angle would be counterclockwise. So that would be 300 degrees. We could also get the same angle by going negative 60 degrees. So if we want to go clockwise, we'll go negative degrees. So some common angles you know are the 90 degrees. So a 90 degree will look like this right here. So 90 degrees will always be this angle. 180 degrees will always be flat, like this. And something like negative 90 degrees will look like this. So if I give you a number, you can draw the exact angle that I'm expecting you to draw, because we always start at 0 degrees and we go counterclockwise. So, for instance, if we want a 150 degree angle, we know that 90 degrees is up on top, 180 degrees is on the left here, so 150 is about right there. So when we draw our angle here, it's going to look like this for 150. Now 310, well, down here is 270 degrees, so 310 must be just a little bit more after that. So that is going to look something like this, 310 degrees here. So we have an angle that goes all the way around like this, and that's 310. So again, these are pretty simple. You already know how to do angles. It's just that we're fixing it at the 0 degree line here, and we're going counterclockwise, so CCW. Now, let's talk about quadrants here. So, we've noticed that we have these 0 degrees, 190 degrees, 180 degrees, sorry, I meant to say 90 degrees, and 270 degrees. This 0 degree mark is also the 360 degree mark. So you know that if you go 360 degrees, you end up in the same point. That's what we're representing here. Now, quadrants, we label these because different triangles or different angles are going to have different trigonometric values. So we divide the grid into quadrants and we name them 1, 2, 3, and 4, going counterclockwise, just so we know what values are happening in each quadrant. So in quadrant 1, x and y are going to be positive. In quadrant 2, x is going to be negative, y is going to be positive. In quadrant 3, x and y are going to be negative. And in quadrant 4, x is going to be positive, but y is going to be negative. So you don't have to necessarily remember these, just remember which quadrant is which, and then you can sort of visualize things and figure out the signs if that is easier for you. So here's a few example questions. What quadrant is 77 degrees in? Well, 77 degrees is less than 90 degrees, and it's greater than 0 degrees, therefore it's going to be in quadrant 1. What about 143 degrees? Well, that's after 90 degrees, but it's going to be before 180 degrees. So this is going to be in quadrant number 2. Now 295 degrees, well, 295 is below 360 degrees, and it's greater than 270 degrees. So this is going to be quadrant 4. Now, of course, we can draw all of these really quick. 77 would be right about there. 143 is going to be about there, and 295 is going to be down here. So if we remember that this is 1, 2, 3, and 4, then it's pretty easy to see that yes, these are the quadrants that they're in. So you can always just draw the angle out and then answer a question like this if it's easier. So now what we're going to talk about is reference angles. Now, reference angles are going to be useful when we talk about specific kinds of special triangles. But for now, what you need to know is that the reference angle is the distance or the angle from the x-axis. Now, how is this different from an angle? Well, if we have an angle like 200 degrees, the question is how far is it from the x-axis here? In other words, what is this angle that I'm drawing in right here? Well, we know this is 180 degrees, and this angle right here is 200 degrees, so it must be the difference between these two, which is 20 degrees. So we say that the reference angle is 20 degrees, because that is the distance from the x-axis. Another example here is, let's look at this angle right here. Now, which x-axis is it closest to? Well, it's on the left side, so it's going to be closer to the left x-axis. And we know that this right here is 180 degrees, and this is 90 degrees, and this angle over here is 120 degrees, so it must be the difference between those 2 points there. So 180 minus 120 is going to be 60 degrees. Now I should mention here that the reference angle is always going to be positive. The reference angle will not tell you what quadrant an angle is in. It'll just tell you how far away from the x-axis you are. So if it's below or above, you're always going to want to make sure that your angle is positive. So for instance, to get the reference angle for the second one here, we can do 180 minus 120, or we could do 120 minus 180, which is equal to negative 60, and then just take the positive part. Doesn't matter which way you subtract when finding reference angles, just take the positive angle you get. Okay, so what about the reference angle for this last portion here, this last angle we have? It's 72 degrees, and okay, this is our line right here. Now, which x-axis is it closest to? Well, it's closest to our 0 degree axis. And what you'll see is that any angle that's in the first quadrant is equal to its reference angle. So this is just going to be 72 degrees because we have a 72 and a 0 there, so clearly the difference is going to be 72. So this is how you do reference angles. Here's a problem for you to do right now. If I make one up right here, here is an angle, and this is going to be 285 degrees. If you want, you can tell me right now what the reference angle is. Okay, so you should see that here's the 360 degree mark. Yes, it's 360 degrees, because if we just do 0 minus 285, we're going to get a really weird number. So we want the distance between these two. So this is just going to be 360 degrees minus, that looks like a 5, I'll fix that. 360 degrees minus 285, and we know that this is just going to be equal to 75 degrees. So that's the reference angle right there. is 75 degrees because that is the distance between 285 and 360. Alright, here's some formulas for finding reference angles. If it's in the first quadrant, it's just going to be equal to your angle. In the second quadrant, it's going to be 180 degrees minus the angle. In the third quadrant, it's the angle minus 180 degrees. And in the fourth quadrant, it is 360 degrees minus the angle. You don't need to memorize these formulas. What you need to do is memorize the procedure, or rather understand the procedure. So if I'm here, then I'm going to find the distance between this axis right here, which is 180 degrees, and my angle. Well, clearly 180 is further along than my angle, so if I take 180 minus my angle, I get the remaining portion. So if you can understand that, and draw them out each time if you have to, that's okay. But as long as you understand the process, how to draw it and how to figure it out, you're going to be much better off than just memorizing these formulas. So don't feel bad if you have to draw a picture, because drawing a picture and getting a question right is going to make you a lot smarter than that kid in the back that doesn't study, gets everything right, and just does it in his head, and is like, oh, I'm so good, but I make mistakes sometimes. I mean, if you understand this, you're going to be better off. Now we're going to kind of jump topics really quick, and this is good for angles, and there's an interesting thing when we talk about reflections with angles, is that it doesn't ever change your reference angle. The reference angles will always stay the same. But what is a reflection? If we have an angle here, theta, and we reflect it across the x-axis, what we're getting is the same angle, except it's going to be on the other side of the x-axis. So we take a point, x, y, and we keep x the same, but we make y negative. So over here, if we have an angle down here, and we call this negative x, negative y, then when we reflect the angle across the x-axis, we are going to get an angle up here that is negative x, negative negative y, which is just negative x, y. So the reference angles here are always going to be the same after a reflection. So this is over the x-axis, which just means you reflect it across the x-axis here. The y stays the same, but the x goes across. So if I have, let's do one here, I have an angle that starts right here. Whoops, wanted to erase that. Here's an angle. I'm going to say it has a reference angle of 60 degrees. What is the reflected angle across the x-axis? Well, that is going to be this angle that has a reference angle of 60 degrees. So that's reflections across the x-axis. Now, let's do the exact same thing across the y-axis. So there's the y-axis. Here is a random angle, x and y. Now let's reflect it across this axis here. And of course this has an angle theta right in here. So when we reflect it across, we're going to get a point at negative xy, and the reference angle is going to be the same as it was originally. Of course, same thing here. If you have an angle like this, then your resulting reflection is going to be over here on this side, because we just swap the x values from an x to a negative x, or a negative x to an x. And it's kind of like having a mirror. So just as practice, here's another angle. Let's put it right here. And we have a reference angle here of 45 degrees. Where is the reflection? So the reflection is going to be, the reflection across the y-axis is going to be right here. and it is also going to be a 45-degree reference angle. So now we've done the x and the y-axis, so let's get a little bit crazier, and we'll do both of them at the same time. So we'll start with an angle here, and let's reflect it across the x-axis. So this angle here should equal this angle right here, and then let's reflect it across the y-axis. So we should have a similar angle right here. So all of these angles should be exactly the same, and you'll see that if we reflect across the x and the y-axis, we just get this nice straight line. So it's a continuation of a line, essentially. So as a practice problem, here is an angle. What is its reflected angle across the x-axis and the y-axis? You can do this in any order. It's going to be exactly the same. So to draw this, you can do the y-axis first or the x-axis first. That could be your first reflection, and then your second reflection is going to end up right down here. So you can see if you reflect across the x, the y, and the x again, you're just going to get this cross. And this will happen regardless of whatever angle you pick. These are how the reflections work. So hopefully you've seen this sort of reflection and stuff before. I'm pretty sure it is in the curriculum for grade 9 or 10. I'm not sure which one, but you have seen angles before. That's why this video is a little bit rushed. But if you have any questions or need me to cover something more slowly, just leave it in the comments below and I will get to it as soon as I possibly can.